welcome to True Projects. In this video, we are going to explain about the project, which is two-stage job title identification system for online job advertisements. Introduction of the project. The project operates in an era characterized by the widespread use of the internet, digitalization of process, and the growing influence of social media, resulting in a vast volume of data that necessitates rapid and efficient processing and analysis for informed decision making. In this environment, the project harnesses data science techniques as a powerful tool to extract valuable insights from large data sets, enabling the classification of diverse data types such as text, images, and video, while streamlining various traditional processes that are often resource intensive. The project adapts to the transformation of the job market from traditional channels to online platforms and job portals, reflecting the evolution of job advertisements. This shift presents an opportunity to analyze and understand job market needs through the vast data shared daily, benefiting various stakeholders including labor market analysts, policymakers, job seekers, and students. The project addresses the non-trivial task of classifying online job advertisements, which are often expressed in unstructured or semi-structured text. The lexicon used by employers in these ads can differ significantly from established occupational classifiers, introducing noise and complexity into the classification process. The project introduces an innovative methodology based on self-supervised and unsupervised machine learning algorithms with minimal labeling requirements. It involves two main steps: classifying job ads by sector and matching them with corresponding occupations. By doing so, the project achieves high accuracy in occupation identification and provides valuable insights into the job market, helping stakeholders making informed decisions. Objective of the project. The goal of the project is to develop an efficient methodology for classifying and normalizing online job advertisements, enabling the accurate identification of job titles and occupations to support data-driven decision-making and career guidance. Employing a combination of machine learning algorithms including support vector machine, naive-based, logistic regression, and BERT for the classification of job advertisements into their respective sectors, utilizing self-supervised and unsupervised machine learning techniques along with customized document embedding strategies and feature selection methods for occupation, recognition, and matching. The project aims to solve the challenge of accurately classifying job advertisements despite their unstructured or semi-structured format, diverse lexicons, and the presence of irrelevant information by achieving high accuracy in occupation identification and reducing the reliance on human-labeled datasets. The project streamlines the process of extracting valuable insights from job market data, benefiting labor market analysis, policymakers, universities, job seekers, and students in adapting evolving job market demands. To implement this project, we need software and hardware requirements. Coming to software requirement, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3. Front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. Coming to the hardware requirements, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to the flow of work, here we have designed various steps to execute the project. The first step is importing the packages. The necessary Python libraries including NumPy, Pandas, C1 and Matplotlib, NLTK, TensorFlow, and Scikit-learn are imported to provide required functionality for data processing, visualization, machine learning, and web development. The next step is exploring the dataset. The jobs dataset is loaded and examined to understand its structure, content, and any initial data insights. This step involves data analysis and data quality assessment. The next step is text processing. The text data within the dataset is pre-processed. This typically includes tasks like text cleaning, which is removing special characters or stop words, etc., tokenization, and perhaps stemming or lemmatization to prepare the text for analysis. The next step is visualization using Seaborn and Matplotlib. Data visualization libraries such as Seaborn and Matplotlib are used to create visual representations of the data, which can include various types of charts and graphs to better understand the dataset. The next step is converting text to TF-IDF. The text data is converted into numerical features using term frequency inverse document frequency, which is TF-IDF technique. This transformation assigns weights to the words based on their importance in the context of the document and the entire corpus. The next step is splitting the data set into training set and a testing set. Here we split the data into training set and a testing set, where we use training set for training the model and testing set for evaluating. The next step is building the model. Here, machine learning models are constructed and we have used SVM, logistic regression, naive Bayes and etc. The next step is training the model. The model is trained using the preprocessed dataset. This involves feeding model with input features, which is TF-ID of text data and the corresponding target labels if it is a supervised learning task. The next step is Flask framework with SQLite for sign up and sign in. Flask, a web development framework, is employed to create a web application. It includes user sign up and sign in functionality with user data stored in SQL database. The next step is user gives input. Here, user inputs the data. The next step is the given input is preprocessed. The uploaded data will be preprocessed, which means the stop words will be removed and NLTK will be applied. The next step will be the trained model is used for predicting the result. The trained machine learning model is employed to make predictions based on the user input. The next step is final outcome is displayed through frontend. The results or the predictions, the model will be displayed through the user interface. Algorithms which are built in this project are support vector machine. It is a supervised machine learning algorithm that is used for classification and regression tasks. It finds the optimal hyperplane that maximizes the margin between different classes of the data points. It is used in this project for text classification tasks. It is known for its effectiveness in handling high-dimensional data, making it suitable for classifying job advertisements into their respective sectors or categories. The next algorithm is naive Bayes. It is a probabilistic algorithm that is based on Bayes' theorem and the assumption of independence among features. It is often used for classification tasks and it is particularly efficient in handling text data. Naive Bayes is a popular choice of text classification because it works well with textual data, making it suitable for categorizing job ads into different sectors or classes. Coming to logistic regression. It is a statistical method used for binary and multi-class classification tasks. It models the probability of a binary target variable taking on a particular value. Coming to BERT, which is bidirectional encoder representations from transformers. It is a state-of-art deep learning model based on the transformer architecture. It is designed for natural language understanding tasks and excels in capturing contextual information in text. It is used when high accuracy and contextual understanding of the text data are crucial. In the project, BERT is applied to improve the classification job ads by considering context and nonsense in the text, which can be valuable for accurate sector identification. As an extension, we applied hybrid model to produce a more robust and accurate result, and it is used for final prediction, and we built front-end using Flask framework for user testing with user authentication. So here we have comparison graphs through which we have evaluated our models. So here we have accuracy score comparison graph where x-axis represents accuracy score of each algorithm and y-axis represents algorithm names. Accuracy is the proportion of correct predictions in a classification task measuring the overall correctness of a model's predictions. And here we have precision score. Precision is the ratio of true positive predictions to the total positive predictions, representing the model's ability to correctly identify relevant instances while minimizing false positives. Here we have recall score graph where x-axis represents recall score of each algorithm and y-axis represents algorithm names. Recall is also known as sensitivity or true positive rate. It is the ratio of true positives to the total actual positives, measuring a model's ability to capture all relevant instances without missing any. And here we have F1 score comparison graph where x-axis represents F1 score of each algorithm and y-axis represents algorithm names. The F1 score is the harmonic mean of precision and recall, offering a balanced measure that considers both false positives and false negatives, making suitable for imbalanced datasets. For execution of the project, first we need to open the code folder which contains source code files. So this is the code folder of the project. This is the static folder. This folder consists of files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. Here we have app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. And here we have the model file, which contain the algorithm information, and this will be loaded into project code during runtime. This is the notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it popular choice for the data science. Here we have the signup.db file. This file is the database file used to store the user information. Now we need to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we need to open the Anaconda prompt. Using the cd command followed by the space, we need to paste the copied path and then click on enter. This command is used to change the current directory to the code folder's path. So here we can see that current directory is changed to the code folder's path. Here we need to type the command which is python space app.py and click on enter. This will compile app.py file. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, which will be the localhost and the port. So here we have the localhost and the port. Now we need to copy this local link provided by the framework and paste it in any web browser. I prefer Google Chrome, so I'll paste it in that. Here we will paste the link and then click on enter. Here we can see that web page of the project is displayed in the browser, and this web page is built by using the Flask framework. So here we can see a sign up link. First we need to click on it, and here we need to enter all the registration details if we are registered newly. I have already registered and I have an account in it, so we'll directly click on sign in. Here we need to provide our credentials, which are the username and the password to log in. So I'm giving my username and the password, and now we need to click on login. We have logged in successfully. Here we can see a text box where we have to give the job description. Based on that, the system will predict which type of job category the job description is. So here we have the sum of test cases, which means job descriptions. So I'm copying the first job description and we'll give this as the input. So I've copied it and here we will paste it. And now we need to click on predict. So here it is predicted that the job title is classified as Cloud Architect. Now we will give another job description. This time we'll copy the second job description and we will paste here. Now we will click on predict. So it is predicted that the job title is classified as Artificial Intelligence. Now we will give one more text. So here I entered other text. Now we will click on predict. So it is predicted that the job title is classified as Big Data Engineer. Now we will give one more text. So here I have entered other job description and now we need to click on predict. So it is classified that the job title belongs to Business Intelligence Analyst. In this way, if we give the job titles and the job description, the system will predict it belongs to which type of category. Now we will sign out. The project successfully addresses the critical need for efficient job and classification and occupation identification in the era of digitization and online job portals. By utilizing combination of machine learning algorithms including traditional SVM, naive Bayes and advanced techniques like BERT, the methodology achieves high accuracy in categorizing job ads into their respective sectors. Through self-supervised and unsupervised machine learning methods, the project minimizes the reliance on human-labeled datasets, offering a scalable and versatile solution for occupation recognition. The methodology effectiveness is demonstrated by achieving an high accuracy in identifying job titles with even higher accuracy in specific sectors, improving data-driven decision-making and career guidance. This project provides valuable insights into emerging job market trends, specifying highlighting sectors with increasing demand for particular skills such as information technology and telemarketing, benefiting labor market analysts, policymakers, educational institutions, job seekers, and students in adapting to evolving employment landscapes.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.